Okay, so thank you everyone for coming. Today I want to talk a bit about my experience as a data scientist in running machine learning models to production. Um, so the reason why I want to give this presentation is because nowadays you see more and more companies are going to adapt to use machine learning models onto production. 72% of the corporations now have machine learning models on production. Usually these are the more smaller models like tabular data. So if you look at more complex data like natural language processing or computer vision, the adaptation is a little bit lower. And one of the reasons why companies are struggling with putting machine learning software on production is because there are a lot of new challenges that arise when you move machine learning to production. So here are a couple of them that are all listed. And as a result, the time to market for machine learning models is very slow. So the average model from training to actually moving to production is roughly 30 days or more. Like 50% of the models are more than 30 days. And this makes machine learning quite slow as a software discipline. So I work at a startup in Amsterdam, and what we do is we analyze 30,000 hours of video data every day in real time, and among 15 countries among the globe. And basically what we do is we try to find enriched metadata using computer vision and natural language processing. And we use this in the fields of VOD platforms and TV operators. So basically we try to analyze their video data to improve their user experience. So one of the products that we have is we try to detect binge markers. So basically these are things like finding the end credit of a program or the intro, so basically you can skip them. Other parts are for skipping recaps in a show. This is another product that we have where we try to automatically generate artwork. So a lot of TV operators have stock photos as their generic thumbnails. And what we do is we analyze their video data to, using AI, we try to find the best thumbnails or other types of posters that they can use in their platform. And another one is a product called chaptering. This is very similar to the functionality that you would see on YouTube, where you have a video segmented into a couple of other topics that we try to automatically detect. And we do that only with 30 people. So as you can imagine, that's quite a challenge sometimes. And today I want to talk a bit about the challenge that we are facing while moving these machine learning models to production to have several of these products. So today I want to talk about 5 lessons that I learned in the last couple of years while operationalizing machine learning. And hopefully this can be a bit of a guideline for what I call the pragmatic machine learning engineer. So that is a bit opposed to, for example, the more research-oriented people or companies. What I see as a pragmatic machine learning engineer is someone who is more focused on trying to get results fast and not trying to move science a bit further ahead, but mostly to get things running quickly. And the first lesson that I learned was, to ask yourself, do you even need machine learning? This was a mistake I had to learn the hard way. When I started out, I had a product owner who came to me and asked me if I was able to detect transparent logos on a screen. So as you can see here on the top, you see that the channel logo is not fully opaque, and as a result, you cannot do RGB values because they always differ. I said, well, of course we can do that. It's not too complicated. So we get to work with it, but slowly we saw that there were quite some edge cases while detecting these logos. So we came through all these kind of clever solutions. So we created a synthetic data set generator to make sure that we didn't have to use a lot of annotated data. But in the end, it was very difficult to find all of them. All these images have a channel logo. I'm pretty sure you will not be able to see them. And the neural network had a lot of issues with that as well. And it was only until a couple of weeks or maybe even months where I started to ask more questions about what was the actual use case. So what we wanted to do was we want to use the channel logo to see if it disappears. It could either indicate that, for example, an ad break would appear or a new program. And this is some information that we try to predict. But looking back at it, it was very easy to do it in a different way. So here you see all these kinds of information that streams already provide to you. So you see in the top left a bumper, and the top of the bottom left you see even just a frame that they announce that the commercials are coming. So the actual problem that we tried to find was way easier, but by defining it as a machine learning problem, it was much more difficult. So the lesson that we try to learn here is that if you start on a new project, always try to think of if there's other ways to do it, because with these kind of logos, it's very easy to just do simple template matching, and that can reduce the time for a product from months to maybe a couple of weeks. So this is what we did in the chaptering example. So a while ago, we had a customer coming to us and asking, can you detect the chapter similar to what YouTube is doing? And what we found was that in some TV programs, so this is a Dutch news program, they actually provide these overlays very easily, which is a perfectly marcation of the start of a new topic. So what we said to them is, if you want to just try it out to see if it would be a nice feature, we can roll this out in a couple of weeks instead of maybe a couple of months if you do it through more complex solutions, like, for example, using speech recognition and then try to find the changes in topics. This is something that one of our interns is looking into right now, and we already see that that's a project that lasts for months, whereas this was only reachable in a couple of weeks. The next lesson is to know what success looks like. So if you start on a new project, try to really understand what do you want to actually achieve. So this is one of the first products that we had when we started out in 2017. So we had a couple of customers that wanted us to know whether we could detect brand logos and people that were associated with a certain brand, so like an ambassador or something. And back in the days, the results of these models were not that good yet. So what we saw was that the precision and recall were pretty low back then. And of course, that is problematic because it leads to false positives. So you write reports with the wrong people that you detect, or you miss a lot. But if you look deeper into it, it was actually not that big of a problem. So here's a visualization of it, because if you go back to the metrics here, usually the standard metrics are used for image recognition, whereas we are working in the domain of video. So if you have an interview with, let's say, this person, and it's an interview of 15 minutes, you only need to find a couple of matches to know when the person is in the video. So as a result, the recall is not that important. The precision is much more important. So the fact that if you predict someone, it needs to be accurate. But if you miss a lot, it's not that bad, because you can flatten it out using, for example, a window size. So what we did was we instead of predicting for every phase, we implemented a certain confidence threshold, and what we saw was that the recall was really low, but the accuracy was already enough to start shipping it, and then later, of course, you can improve if you want to. The lessons here are don't stress too much about the academic benchmarks, but instead think of your own business domain and try to see how it will look like for the end user, because we could improve the accuracy a lot, but it still would not lead to a better product in the end. The next lesson is don't automate everything. I know this is a bit more an annoying lesson, I would say. Of course, we are all developers here, so we would like to automate as much as possible, because it's more fun to do than to do the annoying manual work. But I really believe that you should really feel the pain first, so and then even maybe a bit more. So what I mean with that is that it's very tempting to, once you have your first results in, you have a model running on production, and to try to automate as many steps as possible. So automate the training, automate the evaluation part. But what it will lead to is that you also abstract it away. You don't really see the data anymore, and you automate something at a moment where your mental model of the project is the worst. So if you wait a bit with automating parts, you will increase your knowledge of the domain, you'll see more data coming through, and you start to see the patterns by yourself rather than through machine learning. And in the end, of course, you can automate stuff. So what we did was, after a while, the really boring things like creating the same service over and over again. Of course, you need to automate it after a while, but don't automate everything. That's basically the lesson. Another one is there's no place like prod. I think it's really important to try to ship things as fast as possible to production. It's very easy to have your own data set and you work on it and you feel very comfortable with it. But what we see again and again is that, it's really easy to overestimate your performances on a small benchmark. But after seeing it on production, you will notice all kinds of edge cases, and they're just basically not predictable, even if you think about it for a long time. So my lesson here is just try to ship something, even if it's not finished. Just be comfortable with it. Have the confidence to show unfinished projects. The last one is it takes a village to raise a model. So this is a mistake that we saw, at least in our company, but also with talking with other people. What you usually see is that if you have a project where you need to operationalize some machine learning, there are two scenarios that you see often. One is where you have the data scientists that are fully responsible from training until the operational side of the project. And you have the other scenario where the back-end developers or your DevOps people are fully responsible for the operations, and you have basically a silo forming. So you have a machine learning engineer that would train a model and then pass on the model to the back-end developers, who will then implement it into a service and take care of it. The problem with the first one is that it will lead to a lot of machine learning engineers who are not very familiar with most of the ops knowledge. They try to reinvent the wheel and usually do it in a way that's not as good as whether you use the standard DevOps practices. But on the other hand, if you see that backend developers tend to look at ML ops from a perspective of traditional DevOps, even though there are a lot of differences between them. So basically what you get is pigeonholing and also underestimation of the complexity of the problem. So what you see is that people treat data more as something as storage, rather as, for example, a data scientist would treat data as actually the most important part of the code base. So this is in an ideal scenario, I would say. So instead of having a data scientist try to do everything, or you have a silo where a data scientist would throw a model to a different team who then tries to run with it, rather than you put all the people together and they would talk about the problems from different angles, and you would see that it would lead to a much better operation. So combining the lessons, to wrap it up a bit, first you should really ask yourself, do you really need machine learning for your project? If there are other ways, always try to do the other way. Standard software engineering has a way faster lead time, so I would always recommend to think of other reasons, even though it's maybe very enticing to use the next shiny machine learning algorithm. Usually what you see is once you move to production, it takes a lot of time to iron out the issues. If you don't see really another way, so for example, you see it with things like natural language programming, after a while there are just not enough heuristics that you can come up with. It may be better to actually use machine learning. Start with an interdisciplinary team, so put your DevOps people, put your data scientists together, maybe some data engineers as well, in one team from the start. Clearly define what success looks like, so only focus on that. Don't waste your time on academic benchmarks or anything, so just really focus on what you need to do. Try to ship to production as fast as possible, only if possible, of course, and don't automate everything. Thank you for your attention. Any questions? Yeah.
So when you move the machine learning software to production, what sort of scoring strategy you use, like to evaluate different methods? Like there are different in the market, like precision recall, F score, F beta. So how do you decide like which is the scoring you want to use?
That's a very good question. So yeah, the question to answer whether which metric to use, it depends usually a bit on the domain and on what you try to achieve. Yeah, so the example I gave before with something like face recognition, if you look at a standard benchmark, they would use something like an F1 score, which is a combination of precision and recall. And in our case, we just noticed that if we are able to at least find the people in a video, that will be enough for the customer. So I guess it's a bit of going back and forth with your customer to try to find out what they actually need, and then try to find a metric that comes as close as possible to that. I don't think you can ever really reach to that, but I guess that's a way of both really understanding the business problem and then combine it with what you can find maybe in research, what comes close to it.
Cool, thanks.
Yeah. All right. Thank you for coming and for your attention.